Right, so I'm Colin Campbell, and can we have the slide up? Right, yeah, so I've organised it as past, current interests and future. So in the past, we've been working on machine learning, integrative machine learning methods which take multiple different types of data, particularly drive the status of variants in the human genome. This was actually pretty successful. One of our algorithms was used as the mutation impact predictor at Cosmic in Cambridge, and there's many studies using it. So moving on to the present day, these classifiers use a lot of different types of data which are informative for driver status. Just give you one. If you look at sequence conservation across species, if you have a highly conserved region in the genome, then that tends to indicate functionally important. If you've got a variant there, it tends to indicate it's higher probability of being pathogenic. So initially, we're using 30 different types of data. However, Amy Francis, who's here in the audience, has compiled, we've recently published a thing called Driver Base, which is a resource with many more types of data. In fact, we have 1,500, but we want to add in MAVE data and all sorts of different types of data. So these are, they are cancer type specific. These are our performances. We're getting good scores on unseen data, okay? So like leave one chromosome out. So we're also proposing to marry up, this is a very rich area for research, we're also proposing to marry up these prediction tools to circulating tumor DNA, which is a really exciting area, but I'll stop there.